Okay, in this question, we need to determine the indicated probability for, it says here, a binomial experiment using the binomial distribution table with the given number of trials n, so they're giving you n, and the probability of success p is given. So you have three questions. The first one gives you, and notice that all of them are giving you the same n, just for convenience, of course, but n can be different for different problems. I chose the same n just for convenience of using the same part of the table. But notice that in A, the p is different from the one in part B, different from the one in part C. Okay, and you can see that you are asked in A to find the probability that the number of successes x is 6. In part B, you need the probability of success being 4 or less. This, you can write it as probability of x less than or equal to 4. And remember, when n is 12, and you want probability of x less than or equal to 4, this is the same as probability of x equals 0 plus probability of x equals 1 plus probability of x equals to 2 plus probability of x equal 3 plus probability of x equal 4, because remember that x always starts from 0 until n. n in this case is 12. Just for our example is 12. It could be different. And look at the last one. You have the probability 10 or more. And this is the same as saying we want to find the probability that the number of successes x is bigger than or equal to 10. And remember that x is between always 0 and 12. So to be bigger than or equal to 10, it means that x is 10 or x is 11 or x is 12. So this is just for you to understand what is required from you to find. You want to find probabilities here. So let's go to the first one. I put the table here. You can see that I'm showing you that n is 12 here. Remember that p runs over here with all the different probabilities. But since we are saying that p equals 0.55, you only pay your attention to this column of the table. And then you want to solve probability of x equals 6. Remember that x is here. And so where is 6 in the table? It's here, number 6. And so you just move with the table until you reach the p that you want, and the number that you're looking for is here. So you can say, therefore, from the table, the probability that the number of successes in this trial is exactly 6 is 0.212. This is an immediate question because it's asking x exactly equal to a value. Now let's look at part B of this question. In part B, again, you can see that the n that we have is 12. That's what's given here. N is 12. The p again runs here with all the probabilities of success for given x's. The x's are here in the table. So we want here the probability of 4 or less. But before, we need p equal 0.25. So we only take this part of the table. And so this probability that we want is the probability that x is 4 or less, so it means less than or equal to 4, which is, I will write it here because it should start, x starts from 0 always. If you're doing less than or equal to 4, then it means all the numbers that x can take less than or equal to 4. Notice that you can have 4 or 3 or 2 or 1 or 0. So you need to add the probabilities of x equals 0, x equal 1, plus probability of x equals to 2 plus probability of x equal 3 plus probability of x equals 4. And now you look at the table. The first one, for probability of x equals 0, look, for 0, if I go here, I will find the number 0.032. So I will put here 0.032 plus, notice that 1 is the one right under it, it's 0.127 plus probability of x is 2 is 0.232 plus probability of x is 3 is 0.258 plus the last one, probability of x equal 4 is 0.194. And if you add up these numbers on your calculator, you should get 0.843. This is to 3 digits. As you see in this table, everything is done to 3 digits. So again, the 4 numbers that we added, I just don't want you to not see them, but this is for 0, then this is for 1, this is for 2, this is for 3, and this is for x equal 4. So when you add up these 5 numbers, you get 0.843. That is the probability that the number of successes is at most 4. So 0, 1, 2, 3, 4 from 12 trials. And let's go to the last part. The last part is, again, n is 12. So you look at the part that from your table that has n equal 12. P is 0.7. So in this case, we are looking at 0.7, which is this part here. And notice that we want the probability that 10 or more. So this is the probability that x is bigger than or equal to 10. Remember that x is always between 0 and n in this case is 12. This is only for this case. Okay, you might be asked another question for another n. N is just the number of trials. So whatever it is, you look up the right n from the table. So remember, this will be x bigger than or equal to 10 is probability of x equal 10 plus probability of x equals 11 plus probability of x equals 12. We cannot go above this. And now let's see. We are in the right p here. This is my p, okay, 0.7. And then x is here. And so you want 10 or more. So you want the last 3. 10 or more in my table are these 3 values. The first one is probability of x is 10, so this is 0.168 plus probability of x is 11 is the next one under it, which is 0.071 plus probability of x is 12 is 0.014. And if you add up these numbers, you will get 0.253. And that would be the probability that the number of successes is 10 or more. Remember, this means about 25.3% success that you have, 10 or more successes out of the 12 trials, like 10 or 11 or 12. That's why we add the probabilities, because we're saying or. We want 10 or 11 or 12. And this should make you more comfortable using the table, hopefully. And this, I will end the question here.